back to the Elevens Lab. This is a second video in this series. Today we're going to be talking about shuffling. Now with computers, you noticed that things are pretty predictable. They do the same thing every time. They do it exactly the way you program it. So think about taking a new deck of cards out of the package. Programming it the way we've done it so far is like taking a new deck out of the package, where it's very predictable. If you've ever opened up a new pack of cards, you'll notice that they're all in the same order. Ace, 2, 3, 4, 5, 6, 7, all the way through the one suit, all the way through the next suit, the third and the fourth. They're always the same, and they're always in the same order. So if you were to play a game using the cards the way they are, you'll notice every time you play the game it's predictable because there's nothing random about this. This is all in the same order. But if you were to shuffle things, things get kind of different. You add an aspect of randomness to it. So in order for the game to be interesting and fun, we gotta shuffle things up a little bit. So we're going to talk about today the two different concepts of shuffling. One concept is the perfect shuffle. Now if you notice, I'm going to use this over here because I have them in order. A shuffler will usually split the deck in half, maybe a left half and a right half. And they will take the deck and shuffle it. Now I did a pretty bad, I'm not perfect shuffler, but you'll notice that the idea is I want to interleave every card. So if I have my left hand and my right hand, essentially what I want to do is I want to say one card from left, one card from right, one card from left, one card from right. I'm continuing back and forth going between each deck, taking one card and putting it into a shuffled deck. So this is called the perfect shuffle because I'm taking one card from each deck and putting it into the pile. Now we're going to cut off and go to the code of how can we accomplish this in code. Let's begin by taking a look at the folder for activities in 3 and 4. The second video. You'll see the folder that we're working with is activity 3 for EDU Campbell activity 3 and 4. Alright, looking at the shuffler class, go ahead and click on the shuffler class so we can see that. You'll notice at the top there are two constants, and we'll be playing around with this. But essentially what that means is I'm going to this tells me how many times I want my tester to shuffle and how many times I want how many cards I want in the deck. Now this shuffler is taking a step back. We're not shuffling cards anymore, we're just shuffling integers, so we can easily see the shuffling algorithms and see how they play out. I won't go into that because essentially that's just building it out. What we're going to do is we're going to implement that first perfect shuffle algorithm. So again, we're going to shuffle from the left to the right. So let's pseudocode this out and see what we want to do here. So if we want to initialize the variables, probably in every function you probably want to start off with initializing what variables you know about. The next step is what we want to do is we're bringing in an array of int values. We will want to shuffle the left and the right. So we're going to alternate, we're going to loop through the deck and alternate pulling from left and right sides of the split deck. And then finally we're going to be copying all this stuff into a shuffled array. So we're going to have to copy the shuffled array back into the initial array because we're not returning anything. We want value. If you remember, this is holding a memory address. We can't just set values equal to a new array because this is passed by reference and it's pointing to a chunk in memory. So we want to copy all the values back into the actual object that this points to. So what kind of variables are we going to need for this project? we're going to need to create a shuffled array. So we're going to create an int shuffled equals new int, and back to what we talked about before, this dot value. Let's see if I can find it. Oh, this is a static. Yeah, this dot value count. That's what we want, because this will tell us how many values there are in this pseudo deck that we've created. So we'll have values should have the same count as shuffled in this program. We're going to start off by splitting the deck in half. So how do we do that? Well, really we just want a handle to the positions, the indexes in the left and the right deck. So I'm going to start the left deck starting with the bottom half of the deck. So I say int left deck starts at position 0. So if the first half of the deck starts at position 0, what do you think the right half will be? Right deck. Right deck is going to start at the size of the array divided by 2. So the left half of the deck will start at 0, and the right half of the deck will start halfway through the deck. That's fairly straightforward. Now we're going to loop through the deck, and we're going to alternate the left and the right. So for int I count equals 0, I count less than value count, whoops, I count plus plus. And now we're going to alternate copying the left and the right over. So we're going to say shuffled I count plus plus equals values from the left deck. And to kind of shortcut things, we want to increment to the next card in the next round, so we'll just increment it there as well. So we're going to start copying from 0 to 0. And we'll do the same thing from the right side of the deck. So if you remember the picture we just showed earlier, left deck, right deck, left deck, right deck, left deck, right deck. And we're going to want to, we don't want to increment this because we're going to increment this here so we can go to the next card here, but we're already incrementing it here. You know, it'd probably be easier, cleaner just to leave this blank. Another way to make sure you don't get confused is to leave this, if you remember 4 statements, this last statement is what is executed at the bottom end of the loop. So if we want to keep things consistent, we'll just increment it after every time we set shuffle to the values. Alright, and lastly, we're going to want to copy shuffled back into the values array. So that means we're going to have to loop through this thing again for int I count. I like copy paste. So we want to copy values I count. Actually, let's just into from shuffled I count into values I count. I count plus plus. So we're just looping through 0 to 0, 0 to 0, 1 to 1, 2 to 2. We're just copying it right back into the values array. So that should work. Now, Shuffler has its own main value, its own main function. So again, it's going to it's showing the perfect shuffles and efficient selection, the next algorithm. I'm just going to run through it one time and see if it worked. So again, we're starting from 0 to 7. Now you can see it's kind of shuffled, but there is a pattern to it. Because it's a perfect shuffle, there's a pattern. You notice that because we're doing every other one, it's 0, 1, 2, 3, and 4, then going back to the beginning, 4, 5, 6, 7. So there is a pattern. You might be easier to see if I bump this up. So instead of 8, let's make it a full deck of 52, and let's shuffle it more than one time. So we'll run that. And here you can kind of see 0, 1, 2, 3, 4, 5, all the way to 25, which is half of the deck. Then it starts 26, 27, 28, 29, 30. So there is a pattern to this. It's not quite random. And if you'll look into this, there's actually a pattern between these numbers as well. And it looks kind of shuffled if you go to 4, if you go if you shuffled it 4 times. Well, what would happen if I shuffled it, say, more than 4 times? Let's say if I shuffled it 8 times. With the perfect shuffle, will it be random at the end of the day? Well, if you notice, it actually ended up back at the start. Here is the deck, 0, 1, 2. We started off with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you notice, the 8th time I shuffle this, it ends right back at where we started from. It's all the way back in the rain. In fact, that's a behavior of a deck of 52 cards. If you did a perfect shuffle 8 times, every 8 times, it'll land right back on the same pattern it was before because you're doing a perfect shuffle. So even though it seems like it's random, it seems like it's actually, you get some sort of variation between it, it really isn't that varied. In fact, you'll find that this pattern happens every 8 times with a deck of 52. So if we want to do that, we're going to have to come up with another algorithm. As we saw in the code, when you implement a perfect shuffle, if you do it enough times, you'll come back with the same deck that you had before. Especially in a deck of 52 cards, if you do it 8 times, you'll end up with the same deck. Sometimes the magicians, who are really good shufflers, can implement this strategy. They'll say, hey, take a card somewhere, anywhere in the deck. They won't have to look at it. They'll take it from the deck and stick it on top. Then they'll shuffle it, but they'll shuffle it, or maybe they'll stick it in the middle or something like that, so it'll be out of place. And then they'll pretend to shuffle it. And if you notice, count the number of shuffles. They'll shuffle it 8 times, and it'll make you think that it's completely random. But really what they've done is they've just shuffled it enough times that it came back to the original state. They'll just need to look at the cards and go, oh, the one thing out of place, there it is. So the perfect shuffle really isn't as random as it appears. We're going to implement the second, called a selection shuffle. And if you remember back to our other videos, we talked about a selection sort, and it kind of follows the same principle. So we'll take a deck of cards, and we'll actually take what we'll do is we'll start from the top, and we'll take a random card somewhere between the bottom and the top, pick that out, and switch it. So we'll take this card out and store it on top, and put this card back put that card back in where we found it. So we take a random position, we take the card out, we switch that with the top, and then we go to the next one. So now we have size -1, and we do the same thing over again. I take the top card, and I find some random card inside the deck. I take that card out, stick that on top, switch the places with the 2 cards, and start again. So I keep doing this, and ultimately, every time I pick a random card and do this, I'm going to get a fairly shuffled card. This adds enough randomness to this. Again, I take a random card from the top, switch the places with this, and stick this on the bottom. Let's see how to do that in code. Here we are back at the shuffler, and we're taking again the same int values. Here you can tell in the code that we've actually run it, and it didn't do anything, didn't shuffle anything, so they remain the same. What we're going to do is we're going to implement the selection shuffle, and you'll notice if you compare it against the selection sort that it'll look fairly similar to the selection sort that we did in the past. Initialize variables, there we go. I can spell. It does happen. So I want to start initializing the variables. Then I want to loop through the deck, take a random position in the deck and swap it with the top of the deck. So we'll take a random one, stick it to the top of the deck, and continue on through the deck. So what kind of variables we're going to want to create? Well, we'll create a random number generator. Random rand equals new random, and int I min equals 0. Okay. Notice that Eclipse is flagging it because I haven't imported random yet. I'm going to, because it's Eclipse, I'll just import the class. For those of you that are in JGrasp, you're going to need to import it up here. Now, their math class does have a random number generator, but for this example, I'll just use the random class. So here, I'm going to create a loop for int max equals 0 value count. If you remember that from above, value count tells you how many values there are. We're going to start from the top of the deck, so it's really value count minus 1. So if it's 52, we don't want to go array index out of bounds. We want to start off with count minus 1. Max is greater than 0, so since we're starting from the top, we're going to go downwards instead of upwards. So instead of plus plus, we're going to make sure it's, as long as it's greater than the 0, we're going to just subtract it. We're going to go from top to bottom. Okay, now I want to create, now one thing I notice here is that the nomenclature is different. This is really cool. You see how I have max here 3 times and I have I min. I really want them to kind of be the name the same. So one really cool feature of Eclipse is I want to rename this from max to I max. And you notice as I'm typing, every reference in the code changes without me having to retype it. So that's a really cool feature in Eclipse. Alright, so I'm going from the top to the bottom. I'm going to hold the position until I swap. Now, if this was cards, where right now I min, I max, and I swap represent the indices. Rand.next int. I think it's max. I max minus I min plus 1 plus min I min. So this is an algorithm to make sure I get a random number between the values of min and max. Now, since min is 0, it really doesn't matter. So I could really take 0 out here and just be I max minus 1. But this, if max wasn't 0, this is the algorithm to do that. If it was like, say, between 5 and 52, this would work. So I swap is the index, and now I'm going to hold. If you remember the swap algorithm from the sorts, I need to do 3 steps. I need to hold the value, int hold. Actually, I'm gonna make this different. Hold, instead of I hold, I'm going to say it's hold, because if it was a card, it would be a card instead of an integer, because I'm just happen to be using integers instead of cards. So while I min, I max, and I swaps are indices, this is actually holding the values at I max. So we're going to hold off I max first. Then we're going to swap into values max. Actually, I want the whole thing. Max, I'm going to swap into that. I want to swap in I swap. And then finally, I'm going to swap hold, because I held it, back into the position at the swap. So I want to stick the top card back into the deck and shuffle that again, run that again. So let's see how that fares. I'm going to clean all that stuff out and try it again. And boom, a little more random. You notice that each shuffle seems to be fairly random. No 2 cards. I don't see any card that really kind of matches up against each other. So it does provide a fair level of randomness. So now that we've done that, we're going to see if how this implements over into our cards. We're going to use this in deck. If you remember, we left shuffle blank. So this is what we have from our first video. But shuffle is empty. So I'm a cheater, so I like to copy and paste this algorithm. It seems to work. Let's use it rather than retyping it again. Deck. We're going to make a couple changes to it because we're not dealing with integer arrays, we're dealing with values. So here, instead of an integer, we're going to want, instead of value count, we're going to want size. Okay, now that we have size, we really want to keep the same thing. We want the random number generator, we want min to be 0, and we like this iswap thing for the index. But we're going to size instead of value count. And here, instead of an integer, we're going to hold a card. So let's say card C hold. And instead of values, we want cards. Now, cards is an array list, so we can't use it like an array. We're going to have to use member functions. So to pull something out, we're actually going to pull the card out by saying dot remove. And we're going to remove IMAX. So we get the value card and we hold it, and we take that card off the top of the deck. So now it's gone out of the deck. I'm going to do the same thing with the swap value. I'm going to take that swap card out. I'm going to hold. See, I'm going to call this low for right now. Actually, I should call this high and low. See. High. So this is the top of the deck and this is the bottom of the deck. We're going to want to swap these things. So since I took off the low, I can't stick it back into the high. I'm going to have to stick high back into the middle of the deck because already the deck is 2 cards short and it's going to be smaller, so I can't stick it back where the index where high was until I stick high back in. So I want to stick high back in where I stuck low. How would I do this? So in cards, so it's really cool that the array list can allow you to do this. I'm going to stick high back in where low was. So add, and I want to add at where iswap is. I want to add high. So I'm going to take the top of the deck and stick it in the middle of the deck where this random place at the middle of the deck. Delete. And I'm going to do the same thing with the low. I want to take the low card and stick it back at the top of the deck at IMAX. Done. Alright, so that seems fairly easy. Let's take a look at the deck tester and see. This is a different, let me clear all this stuff up. So here in the main, you can see that we're doing Jack, Queen, King of 2 different suits, blue and red. So we're taking a fictional suit, blue and red, and just assigning them point values. And we're going to take the deck and we're going to print out the deck, deal a card, and notice that we're going to call the shuffle when we create the deck. So remember, at the bottom of the deck we have the function shuffle. So let's run the deck tester and see if it actually shuffled the cards. Alright, this is the first set. Here you can see it's Queen of Blue, King of Red, Jack of Blue. It looks like it's fairly well shuffled. So let's remember this and let's run it again and see if it's the same. Queen of Blue, King of Red. Let's see if that's right. The same thing this next time around. Queen of Blue, Queen of Red, not King of Red. King of Blue, King of Red. So we've implemented a fairly good shuffling algorithm. That's it for video 2. The next one, we're actually going to go into the Elevens game and describe what the game is and how it functions, and maybe put some meat on the bones of that. Thanks for watching.